Alright, here we're looking at using exponential equations. Um, so let's look at this problem. At the peak of a beanbag animal fad, sales representatives sold 12,000 of the animals a month. Each month after that, the reps sold about 2% fewer. About how many beanbag animals did the sales rep on the 6th month? Alright, so this is going to be our A value. Now remember, we're going to use the general formula y is equal to A. Now, it's going to be the 1 plus or minus. We've got to figure out if it's a growth or decay, the rate, and then to a variable. Now, in this case, it's going to be t for time. So A is what we start out with, so I would write 12,000 here. Then 1, I'm going to subtract because we're decreasing, so it's a decay. Now remember, we're going to change the percent to a decimal, so move it over 2 places. So it's going to be 0.02, so it's going to be minus 0.02. Okay, and then t will be our variable that we're changing. Now sometimes you'll see it as like f of t. That just means it is a function. I'll take it either way for right now. But I'm going to go ahead and clean this up so I get 1 minus that would be 0.98 to the t power. So if you're asked to model it or asked to make a function, that's all you'd have to do. Now to figure out how many beanbags he's selling in 6 months, we simply just put 6 in for t. Now this is we're told that it's 2% for every month. Okay, so t will be in months for this one. So we'll have 12,000 times 0.98 to the 6th power. And then that'll should give us one of these values. Now if we look at this, it's a bad multiple choice question because everything increases except for this one. But mathematically, if we put this in, we come up with this and then some decimal out here. But we're going to round to a whole number. So you should end up with 10,630 beanbags. Animal beanbags is what he's selling. Alright, now this one you have to work backwards a little bit. Let's see what we have. Okay, in 1790 the population of the U.S. was this. Okay, 3.93 million. By 1800 this number had grown to 5.3 million. It says write an exponential function that could be used to model the U.S. population y in millions from 1790 to 1800. Write the equations in terms of x, the number of years since 1790. Okay, so x will replace t. It's just a variable, but let's look for this. So y is equal, now what did we start out with? We started out with 3.93, so that's going to be our A. So 3.93, and we know it's going to be 1 plus or minus something. Well, we don't know what this is yet, so I'm going to put that in as B, and we're going to kind of work back, because that's going to be our base to the t power, or x in this case. We know that from 1790 to 1800 is 10 years, so that's our exponent, is 10. And we know what y is. It's 5.31 million. So that number should be over here. So basically what we're going to do is end up solving for this. Okay, so we're going to undo this by division. So we divide both sides by 3.93. And when we do that, we get 1.35. We get a lot of other stuff, but we're going to round to 2 decimal places. Is equal to b to the 10th. Now to undo this, we're going to take the 10th root of both sides. Okay, now when we do this, now I may have to show you on your calculator how to do this, but calculator should handle this. We're going to take the 10th root of both sides. Okay, and so we end up with 1.03 as our base. So to come up with the equation over here, we'd have y is equal to 3.93 times 1.03 to the x power. And that would be the equation, or the model, the function that would give us our values for the population for any year between 1790 to 1800. Now if you look at this, we could eliminate some answers just by looking at it, because the A is what we started out with. So those are not possible choices. And then here, you could also work backwards since it's a multiple choice question. If I put in 10 here, it should give me the 5.31 because I know what happens after 10 years. But either way, it should be B for our answer. Alright, so here we have a freight question. Alright, we're in the United States, 580 billion tons miles in 1960. So that's going to be our A. It's what we started out with. So y is equal, well actually they use f of t, so we'll use f of t. Remember that's just functional notation. That's our range, it's what we're getting out, same idea as y, but this tells us that it is a function. Alright, so 580 is what we started out with. Well, that doesn't help us eliminate anything because they all have 580. So, but let's look. At an increase, so we know that it's going to be bigger than 1. Okay, so that's not, the base is not bigger than 1 there, it's not bigger than 1 there. So it's going to have to be one of these two. Now, what we're going to do is, remember, it's going to be 1 plus, okay, our rate. So we're going to move this 2 places over. So it's going to be 0.0232 of the decimal. And then t is our variable. So f of t is equal to 580 times 1.0232 to the t power. And that's how we would set it up. Now to use it, again, we could plug in any number we wanted to, any number of years, assuming that this still holds. So if we wanted to figure out in 1970 what it's worth, we'd put in 10, and so on. Alright, in this one we're going to have to come up with a model and then actually use the model or use the function to come up with a number. Okay, according to the Population Bureau, the world's population in 2000 was 6.1 million. So again, we're starting, that's going to be our A because that's what we're starting out with, 6.1. And I'll just use Y for now. So 6.1, okay, and then we're going to have to figure out 1, is it plus or minus? Well, it's increasing, so it's going to be a plus. Our rate of increase, which is 1.4, but we're going to convert that to decimal, so we get 0.014. Okay, and then to the number of years. So to clean this up, it would be 6.1 times 1.014 to the t. Now from the year 2000 to 2020 is 20 years. Our rate was for years, so we're going to put in 20 here. Alright, so we end up with 8.055 billion. Okay, so it's going to increase by over, close to 2 billion people from 2000 to 2020. And this was our answer. Hopefully this helps. There'll be more questions. Most of your questions will be of this type, or the ones where you actually have to figure out the base. Not so much. So like question number 2, I wouldn't spend as much time on.